October 2025. Astronomers saw something impossible streaking toward us. Not one interstellar visitor, but two. The second, 100 times bigger than anything we've ever tracked. And it's heading straight for the first. Right now, somewhere in the darkness between stars, something massive is closing in on our solar system. Not a comet. Not an asteroid. Something so enormous it makes every other interstellar object we've discovered look like a grain of sand. And here's where it gets strange. It's not just passing through. It's moving toward another visitor. A collision course, a rendezvous, or something else entirely. The first object, the one we've been watching since earlier this year, is called 3IATLAS. When we found it, we thought it was remarkable. An interstellar comet over 5 kilometers wide, carrying more than 33 billion tons of ice and rock, bleeding water and carbon dioxide as it falls toward the inner solar system. The third confirmed visitor from beyond our sun's gravitational reach. Already it broke records. Already it changed what we thought we knew about objects wandering between the stars. But then in September 2025, solar monitoring spacecraft picked up something else. A signal, a brightness spike, an anomaly so large that at first scientists assumed it was an error. It wasn't. What they found was an object 100 times the size of 3IATLAS, bigger than mountains, bigger than cities, an interstellar giant, hurtling through space on a trajectory that shouldn't exist. And the data shows something nobody expected. It's not just entering our solar system, it's heading toward the exact region where 3IATLAS is traveling. Same neighborhood, same timing, same impossible coincidence. Two interstellar objects, one system. One question that refuses to go away. Is this really just chance? Let's go back to what we know for certain. 3IATLAS was first detected earlier in 2025, catalogued as the third confirmed interstellar object ever observed by humanity. The first was Oumuamua in 2017, that strange elongated visitor that tumbled through our solar system and sparked years of debate. The second was 2I Borisov in 2019, a more traditional comet that looked almost comfortable, almost familiar. But 3IATLAS? It shattered the scale. Over 5 kilometers across, far larger than its predecessors, outgassing massive plumes of water vapor and carbon dioxide as solar radiation began to strip away its icy surface. Astronomers watched it closely. They measured its composition, tracked its velocity, calculated its origin. The data suggested it came from somewhere deep in interstellar space, a wanderer ejected from some distant star system millions or even billions of years ago. Its trajectory was hyperbolic, meaning it wasn't bound to our sun. It would pass through, swing around, and vanish back into the void. A brief visitor, and a cosmic traveler with no intention of staying, but that was before the second object appeared. In late September, spacecraft equipped with solar observation instruments detected a sudden, intense brightening in a region of space far beyond the orbit of Neptune. At first, mission controllers thought it might be a solar flare reflection, a glitch in the sensors, or interference from cosmic radiation. But when multiple instruments confirmed the signal, and when ground-based telescopes turned their lenses toward the coordinates, they saw it. A massive luminous object moving through the outer edges of our solar system. And when they ran the calculations, when they mapped its trajectory and extrapolated its path, the numbers told a story nobody wanted to believe. This new object, this giant, wasn't just entering the solar system. It was converging on the same spatial region as 3IATLAS. Not the same orbit, but close enough that the coincidence felt impossible. Two interstellar visitors, arriving within months of each other, moving through the same cosmic corridor. The odds of that happening by pure chance? Astronomically small. So what are we looking at? What is this 100 times larger object, and where did it come from? The initial images are stunning. Even from billions of kilometers away, the object appears bright, far brighter than 3IATLAS, suggesting either a highly reflective surface or active outgassing on a scale we've never witnessed. Its size is difficult to comprehend. If 3IATLAS is 5 kilometers wide, this object could be 500 kilometers across, maybe more. That's not a comet. That's not an asteroid. That's a world, a rogue planet, a fragment of something even larger, torn from its home system and cast into the endless dark. Some astronomers have begun calling it a super-interstellar object, though the term feels inadequate. Others hesitate to classify it at all, waiting for more data, more observations, more certainty. Because here's the problem, we don't have much precedent for this. We've only confirmed 3 interstellar objects before this. Our models, our simulations, our understanding of how these visitors behave, all of it is built on a sample size of 3. And now we're facing something that rewrites the rules. The brightness variations suggest the object might be tumbling, rotating as it moves, exposing different surfaces to sunlight. If it's outgassing like 3IATLAS, the scale of the plume would be enormous, potentially visible even with amateur telescopes once it gets closer. But there's another possibility, one that researchers are hesitant to discuss publicly. What if the brightness isn't from reflected sunlight? What if it's thermal emission, heat, energy, something radiating from within the object itself? That would change everything. Let's talk about trajectories. When an object moves through space, its path is determined by gravity, velocity, and the forces acting on it. For something traveling between star systems, those forces are minimal. No atmosphere to slow it down. No significant gravitational wells to curve its path, at least not until it gets close to a star or planet. So interstellar objects should move in relatively straight lines. Gentle, hyperbolic curves, influenced only by the stars they pass. But when scientists plotted the trajectory of this massive new object, they found something strange. The path isn't quite what they expected. There are subtle deviations, tiny adjustments that don't match the predictions. It could be outgassing, jets of gas pushing the object slightly off course, the way sunlight pushed Oumuamua in unexpected ways. Or it could be something else, gravitational interactions with unseen bodies, perturbations from dark matter, or in the most unsettling scenario, course corrections. Nobody is saying that out loud, not officially. But in private conversations, in research meetings behind closed doors, the question is there. What if this object's trajectory isn't random? What if it's been adjusted, aimed? At this point you might be thinking, aimed at what? And that brings us back to 3IATLAS. Because if you wanted to intercept another interstellar object, if you wanted to rendezvous with something moving through the solar system, you'd need to calculate trajectories years in advance. You'd need to know where the target would be, when it would arrive, and how to match velocities. You'd need precision, intelligence, intent, and that's where the data gets uncomfortable. The convergence point, the region where both objects' paths seem to intersect, is somewhere beyond the orbit of Jupiter, probably in the asteroid belt or just beyond it. Timing estimates suggest they'll reach that zone within the next few months. What happens then? Do they pass each other at a distance, 2 ships in the cosmic night? Do they interact gravitationally, altering each other's paths? Or is there something more? Some researchers have proposed that the larger object might be a shepherd, a massive body that gravitationally influences smaller interstellar objects, capturing them or redirecting them. That's a known phenomenon with moons and planetary rings, where larger bodies corral smaller ones into stable orbits. But applying that concept to interstellar space, to objects crossing light years of emptiness, feels like a stretch. The distances are too vast, the velocities too high. The precision required would be extraordinary, unless, of course, this isn't the first time it's happened. Unless there's a pattern we haven't seen yet. A network of interstellar objects moving through the galaxy in coordinated paths, guided by forces or entities we don't understand. It sounds like science fiction. But then again, so did the idea of interstellar visitors before we actually found them. Let's consider the alternatives. What if this is natural? What if both objects were ejected from the same star system, perhaps during a catastrophic event, like a supernova or a planetary collision? That would explain why they're traveling in roughly the same direction, entering our solar system around the same time. They could be fragments of the same parent body, torn apart and scattered across interstellar space, now reuniting by chance. But the math doesn't quite work. Ejection events like that would scatter fragments in all directions, not send them on parallel paths that converge millions of years later. The velocities would differ. The trajectories would diverge. And yet here we are, watching 2 objects that seem to be moving as if they know where the other one is. Then there's the possibility of a gravitational slingshot. Maybe the larger object passed through another star system, one closer to our sun, and used that star's gravity to accelerate and redirect itself. That could, in theory, place it on a trajectory toward our solar system. And if 3IATLAS underwent a similar maneuver, perhaps at a different star, they could both end up here, converging by sheer cosmic coincidence. The odds are still staggeringly low, but not impossible. Or maybe we're thinking about this wrong. Maybe the convergence isn't about the two objects at all. Maybe they're both responding to something else, a gravitational anomaly, a massive unseen body lurking in the outer solar system, the hypothetical Planet 9 or something even stranger. If there's a large dark object out there, something we haven't detected yet, it could be influencing the paths of interstellar visitors, bending their trajectories, pulling them toward a common region. That would explain the convergence without requiring intent. It would make this a natural phenomenon, a product of gravity and motion, not design. But it would also mean there's something in our solar system we've missed, something big enough to affect objects billions of kilometers away. And that raises its own set of questions. Scientists are scrambling to gather more data. Every major observatory is being pointed toward the new object. Space agencies are reviewing mission plans, wondering if any existing spacecraft can be redirected for a closer look. Amateur astronomers are sharing images and coordinates, trying to confirm the trajectory, calculate the size, estimate the composition. The global astronomical community is united in a singular focus: figure out what this thing is before it gets too close. Because here's the reality: we don't have a lot of time. If the convergence is happening in the next few months, then every day of observation is critical. Every piece of data could reveal something new, something that changes the picture entirely. And if this object does something unexpected, if it deviates from predicted paths or exhibits behavior we can't explain, we need to know immediately. The media coverage has been cautious. Most news outlets are reporting it as a significant astronomical discovery, a rare event, a chance to study interstellar objects in unprecedented detail. They're emphasizing the scientific value, the opportunity to learn about the composition of distant star systems, the formation of comets and planets beyond our sun. And all of that is true. But beneath the measured headlines, beneath the carefully worded press releases, there's a tension, a sense that we're watching something unfold that we don't fully understand. Social media is less restrained. Speculation is rampant. Theories range from rogue planets to alien probes, to remnants of ancient cosmic civilizations. Some people are calling it a harbinger, a sign of change, a message from the universe. Others are dismissing it entirely, insisting it's just a big rock and nothing more. The truth, as always, is probably somewhere in between. But the fact that we're even having these conversations, the fact that serious scientists are entertaining possibilities that once belonged only to fiction, tells you how extraordinary this moment really is. We are living in a time when the cosmos is revealing itself in ways our ancestors could never have imagined. We've discovered thousands of exoplanets. We've detected gravitational waves from colliding black holes. We've photographed the event horizon of a supermassive singularity. And now we're watching as two interstellar objects, one impossibly large, converge in our own solar system. The universe is not static. It's dynamic, chaotic, full of events and encounters that defy our expectations. And maybe that's the real answer. Maybe this convergence isn't a mystery at all. Maybe it's just a reminder that space is vast, that the forces shaping it are powerful and complex, and that coincidences, no matter how unlikely, are still possible. Two objects, ejected from distant stars wandering the galaxy for eons, happen to pass through the same small region of space at the same brief moment in time. It's improbable. It's extraordinary. But it's not impossible. Or maybe there's something more. Maybe the universe is trying to tell us something, that we're not as isolated as we think, that the space between stars is not as empty as it seems, that we are part of a larger story, one that spans galaxies and ages, one that we're only beginning to read. The next few months will be critical. As both objects move deeper into the solar system, we'll get clearer images, more accurate measurements, better data. We'll see if they interact. We'll see if the larger object exhibits any unusual behavior. We'll see if our models hold, or if we need to rewrite them entirely. And maybe, just maybe, we'll get an answer to the question that's been haunting astronomers since September. Why now? Why here? Why these two objects at this moment in this place? The universe doesn't owe us answers, but we're going to keep asking the questions, because that's what we do. That's what makes us human. We look up at the night sky, at the impossibly vast darkness punctuated by points of light, and we wonder. We calculate, we search, and sometimes the sky looks back 100 times bigger, targeting 3IATLAS, or converging with it, or following it, or being drawn to the same unseen force. The words we use matter less than the reality they describe. Something enormous is entering our solar system, and it's not alone. And whatever happens next, whether it's a cosmic coincidence or the beginning of something we can't yet imagine, we're here to witness it. Maybe the answer is older than our telescopes, older than our civilization, older than Earth itself. Subscribe if you want to see what happens when they meet.